So good morning to everyone, and thank you for your time today in attending today's CPD webinar. My name is Whitemore, and I'm the Technical Product Manager here at Garland UK. And today in the CPD, we'll be covering how we avoid common roofing defects, and towards the end of this presentation, we'll be doing a short Q&A session. So please use the chat box provided, and my colleague Charlotte will be monitoring that, and we'll go through some questions at the end of this CPD. So firstly, a brief introduction to Garland UK. Garland UK was established in 2001, and we aim to be a high-performance provider of waterproofing systems, working on a number of sectors such as the commercial, residential, and industrial sectors. We're a subsidiary of Garland Industries, which is a US-based business, which is currently a $1 billion operation, and this was established in 1895. We work with building surveyors, architects, and facilities managers, delivering industry-leading technical expertise with the aim of lifting the overall knowledge of the construction sector. We have technical managers across the UK, and they are unique in the way that they provide a single point of contact for our clients, helping across the whole range of survey, inspection, and through to on-site and aftercare. So what we'll be covering today in this CPD, we'll be looking at various different types of waterproofing systems that you commonly come across, and how we specify them, and how we specify them correctly to the right application. And we'll also be talking about the tools and techniques that are available to you in terms of surveying and on-site. And the main chunk of this presentation will be about how we come across common design, aesthetic, and application defects with roofing products. And finally, we'll be wrapping up with what we should be expecting from our suppliers and manufacturers in the industry, and what you guys should be looking at as designers and specifiers in the industry. So here are the 4 types of roofing systems that we'll be looking at today. We'll be looking at modified bituminous membranes, metal profiles, cold applied liquid coatings, and green roofing systems. And what we're going to do here is we're going to go through the basic advantages and disadvantages and where these systems can be applied. So firstly, modified bituminous membranes. These are typically multi-layered systems where we have a modified bituminous membrane that's typically reinforced with either a polyester or a fiberglass mat. Or alternatively, you can have a composite which is made of a polyester and a fiberglass mat. In recent technologies, there's various applications such as torch-on or self-adhesive. Self-adhesive is becoming much more popular in terms of safe to torch, being much safer on site and trying to avoid the risk of fires on site. Bituminous membranes are very easily workable and easy to repair. You simply apply heat and you can make repairs relatively easily. And the products are very flexible and durable. They have a huge longevity and last particularly long in comparison to some of the other products available on the market. One of the disadvantages is these do require skilled contractors to install, and the vast majority need to be safe to torch trained, as this is now a legal requirement for these installers, post various fires that's happened on site in the past 10 years. And the applications are broad. We can use them on commercial, residential, and of course refurbishment, replacement, and new build. And we're going to look at a precedent project here, and we're going to underline the challenges and what the outcomes are. So this is a Midland hotel, I believe in Manchester. And the issues we had here was a single ply system that was failing. And after a survey, we were understanding that 20% of the roofing system was completely saturated. So we're then understanding that we need to strip up at least 20% to remove that insulation and then replace it. And with doing so, we designed a tapered insulation scheme, which meant we were removing any ponding water that was also understood on our survey, and we upgraded the U value, replacing the saturated insulation that we also understood on the survey. But it was fundamental for this project that the business remained open throughout the entire operation. So we're able to do this with localized work, and the entire operation meant that the hotel was remain operational during all hours, and there was no loss of business to the company. So we're going to touch upon some metal roofing systems, and the 3 main ones that you'll come up against, or you'll find on the market rather, are typical or traditional metal cladding, composite panels, and also standing seam systems. So traditional metal cladding is a preformed steel that can be coated and either comes in a twin or a single thin application. That's your mouse neck. And the benefits of having a twin skin application is that you can insulate between the inner and the outer panels. This is a very economical system, and typically find this within the industrial sector due to the economy and how fast the system works. The disadvantages is that you're prone to leaking. Where you're penetrating the system with fixings, if these aren't torqued up to the right torque settings as recommended in specifications, you're opening up the risk to leaks. And also, if not regularly maintained, the protective coating applied to the steel can easily disintegrate or come apart during the lifespan of the product. And as mentioned, this is typically used on industrial sectors, but we also do use it in commercial applications, refurbishment, new build, and also replacement if there's a failing cladding or roofing system. So metal composite panels. This is very similar to what we would class as a twin skin system for traditional wall claddings we've seen in the previous slide. Apart from this is pre-manufactured in a factory, and it comes as one item to site with an inner outer panel with insulation sandwiched between. And having just this one element as part of construction means that there's a hugely fast install. You can have a huge fast install, and you can cover huge amounts of space in a small amount of time. But when we come to disadvantages, this is very similar to the previous slide. If we haven't got the correct fixings or they're not torqued up to the correct specification, you are prone to exposing leaks. So we always recommend that you follow manufacturer's details and specifications of fixings. Again, the coating can come off, which I won't cover again. And we're also restricted by panel lengths and accessibility to site. So if we have a real stringent and tight site we need to access, having a long Arctic line with a 12 or 14 metre panel may not be possible. So therefore you can have cuts in panels in the transversal direction, which means you're opening yourself up to compromising the waterproofing performance of your metal panel. And the applications are going to vary. Commercial and industrials where we'll typically see this being used, and we can use on new builds, existing, and refurbs. And finally, the metal systems, we're going to cover standing seam. Also very quick installation, and this offers designers huge design freedom, as we're not limited in terms of design, we're not limited in terms of site access. These, if we are constrained to site access, which gives the designer complete open freedom in terms of the roll profile, the length, we can also taper or also chamfer the edge of these panels without too much hassle. But the big advantage you get with this is there's no mechanical fixings in this system. It simply clamps together and you're not reliant on mechanical fixings. So you're immediately getting away from the risk of either incorrect specification of your fixings or having the incorrect torque and the EPDM wash not being compressed and having the risk of leaks. This is typically classed as the most long-lasting waterproofing system in terms of metal, and you'll never have transversal joints I mentioned in the two previous slides. This system can work on a low pitch, as little as 1.5 degrees, but the other systems you're utterly reliant on having at least a 4 to 6 degree pitch, depending on where you are in the country and what weather and wind you'll be subject to. The disadvantage is this is a generally more expensive system, and some systems at standing seam, this is only some, are susceptible to thermal expansion, which can lead to seam cracking, and ultimately the seams coming apart, which inevitably leads to leaks. And these are typically used on the residential and commercial sectors, and again, on all types of projects. We're seeing it a lot on new build, it's becoming quite preferable with PV fixings, but also it can be utilised on refurbishment and replacement projects. So for metal, we're going to look at this project to Alderley Park Science and Innovation Campus. This was previously the home of AstraZeneca, which I'm sure you guys have heard on the news recently in response to the COVID outbreak. And the new building owners identified that there's a huge atrium space. It was 2,800 square metres, I believe. And what they decided to do was to encapsulate this space and create more office space. So under this courtyard, we had a free pitch standing seam metal roof, and it was actually the largest in the UK. There's a 30-year guarantee that comes part of this, and as part of the project, we had a metal system. We also had membrane, a bituminous membrane, and also a liquid. And incorporated into this standing seam roof, there was actuated roof lights and also siphonic drainage. That demonstrates the flexibility of standing seam system. And lastly, we're going to talk about, we've got green roofing also. We're going to talk about cold applied liquids. The advantages here is this is easily applied, and we can do it with a whole number of substrates, such as asphalt, mineral felt, single ply. It's typically not particularly good on TPO or EPDM, so we need to be careful there. Metal roofing, asbestos, and metal decks. Asbestos, obviously, we have to be careful working with that. We all know the risk associated with asbestos. It's great for complex detailing. As it's liquid applied, you can change it to any sort of roof geometry or tricky detailing you have. And depending on the roof coating, it can be UV resistant, whereas some membranes or waterproofing systems do degrade heavily with UV. And the disadvantages commonly associated with the liquid coatings is this it's completely utterly reliant on the weather being hot or cold. As if it's too cold or too hot, it completely affects the curing process. And you cannot apply it over silicone-based coatings that simply will not bond to it, and it'll be fading pretty soon. We typically see this used on the commercial and residential sectors. And again, you can do this on new build, existing, or if you're simply upgrading a roof that's at the end of its lifespan and you want to give it a new coating to last another 20 or 25 years. And here's our precedent project we're going to look at, which is Kingsway Gardens. There's a balcony leak on a whole number of blocks. I think there's five blocks in total, multiple levels. As a result, what we've seen as part of the survey is that the asphalt roof underneath was showing signs of wear and tear, and there's loads and loads of patch repairs that quite obviously weren't working. And as a result, the insulation beneath was completely saturated and compromising the U value to this residential block. Again, we were very much up against it in terms of minimal disruption for the residents. They use their balconies frequently for access. So we had a very limited period to get this installed. So we used a fast curing product, which each layer cures within 20 to 40 minutes. So the whole system can be done within a day. Therefore, we're helping the residents in terms of getting in and out, and also providing them a new waterproofing system that's homogeneous and getting rid of all the issues they've been experiencing. With this, there's a 15-year guarantee, and you might see the slight texture in this top surface where a quartz was added to provide the anti-slip to the residents should there be a downpour and you need that extra grip underfoot. And lastly, of our 4 systems we're looking at today is our green roofing systems. So this typically integrates a layer of green or vegetation over the waterproofing layer, and we have extensive and intensive systems out on the market currently. When we look at extensive, these are very low maintenance roofs that typically require maintenance either once or twice a year, depending on if we have a drought or if there's any invasive species that manage to establish themselves within the cedar matting on top. Hardy species are typically used as these need to be susceptible to drought. Plants or species that are not susceptible to drought will inevitably fail, and the whole idea about the system is that it's minimal maintenance. The system's not very big in terms of build-up, and therefore the structural load that will be subjecting to the structure beneath is relatively limited when in comparison to some intensive roofing systems. It can be wind resistant, as we know that wind uplift is a concern of some designers. We can be using this also on a sloped pitch roof, as well as a flat, with some additional shear connectors and shear boards, as they're called. It improves air quality. Within a year, the standard ceiling green roofing system will absorb the equivalent of 1.79 kgs of CO2 per year, so that's advantageous for us. I mean, it's a desirable aesthetic. I mean, we've seen lots in the borough of Camden currently, where green roofing is becoming part of planning applications, and I can only see that growing out from London to other planning authorities around the UK. Disadvantages, we've already mentioned that we have to have drought-tolerant plants, otherwise it simply won't survive. And applications, we can use this anywhere. So long as there's a roofing system beneath that supports having a green roof over, we can use it on refurb and new build and the like. So intensive, this is where we have a much deeper substrate, or soil as you may refer to it, where you can have trees, lawns, and all other types of big living items. This increases biodiversity. You'll see a huge amount of wildlife grow, and you can incorporate beehives, you can have timber logs, all sorts of things, mounds, rivers, streams, that the endless design flexibility of intensive roofs is great. But the big problem is how intense it is in terms of labour and the structural stress you'll be putting on the frame. Some of these systems can be up to 300 kgs a metre square, which is crazy. And that's simply due to the depth of the substrate to hold trees, hold plants, or lawns. So that's something we really need to understand at the design stage, or if we're trying to do this retrospectively, it's very unlikely your structural capacity of your roof to be able to build an intensive system without major works. So in application terms, we see this mainly on residential and commercial premises. Although it can be worked on replacement, it's not so likely because of the structural capacity limitations. So mainly we see this on new builds, particularly in cities, so try and increase greenery. So our Preston project here is Porfield Manor, which is down in Cornwall. We had a number of challenges here where we had to comply with some low slopes as part of the planning application, and we had to blend in with the local and surrounding landscape, as you can see in the photo to the top right. However, as we're on a coastal location, we had challenges in terms of strong winds and also weather conditions. And underneath the system, we put an anti-root membrane, bituminous anti-root membrane, which you're going to need underneath the green roofing system. And also we upgraded the thermal performance of this roof, not only with the insulation, but the green roofing also complements and adds to the thermal performance of the building. And this system was a 25-year guarantee. So now we've covered the advantages and the disadvantages of some of the roofing products we have available on the market today. I'm going to hand you over for a video to one of our technical managers, Paul Ball, who's going to take you through the fundamentals of a roof survey and what you should be looking out for.
So we've got a few things that we need to determine. I need to know what the existing build-up of the roof is. So that's going to tell me the thickness of the insulation, because the other thing the clients asked me, and it's a prerequisite of the building regulations, is that we provide insulation on this roof to satisfy Part L. So it's important that I know the thickness of the insulation. It's important I know how much water is in the system, because that will determine whether or not I take the roof off or whether we overlay it. I've got to look at the skylights. I can see just from a visual inspection that they're not very good quality. With all our components, we'd like to put them back with items that have a lifespan at least equal to the roof that we're going to put down. So I can see, first of all, that there's outlets that are too high. They won't be helping with the ponding water. So I know we need to reduce those outlets in height. I think a lot of these roofs are have had a bit of an issue because the lead's been taken by vandals at some time. There's also a lot of change in materials with metal and single ply and other components. I'd like to try and get rid of all that if I could, and make and simplify it with the system that I'm going to specify. Okay, so I'm going to core test this roof to try and determine what the existing build-up of the roof is and find out what type of deck's in place. I'm looking around and I'm thinking, I know from experience that anywhere adjacent to the outlet is probably going to be the place where there's most amount of water. So I'm going to go over here and cut an hole now. So fortunately there's no ponding water about here. I did actually ask the contractor who's doing some repairs on site at the moment to drain this roof partially so I can see where the low areas are, which would help me come up with a tapered insulation scheme if we need it later on. So I'm going to go ahead and cut through this single ply. I can see now the insulation's dry. I can see that this around close to the outlet is actually dry insulation. So I've got down to the deck now. It's a pretty solid deck. Right, I can see that there's asphalt there. So originally this roof, when it was first built, had an asphalt roof on a concrete deck. People have since gone back. They've used the existing asphalt as a vapor barrier. There's no separate vapor barrier in place, and then there's PUR insulation, which looks like it's a good thickness. So I've learned from this that the roof's dry. I'm going to do a series of cutouts around here just to make sure that this is the case in every location. I'm going to remove this single ply I'm going to bond some more insulation on the top, and then I'm going to put 2 layers of torch-on waterproofing. I'm going to remove these cappings so I can extend the waterproofing to the outside edge. The good thing about the extra 20mm of insulation that I'm going to be putting on here, it allows me to sump the outlets in the existing position, because I'm sure a lot of this ponding water is because of this outlet being high. Okay, so I've come down to this gutter section of the roof. This is where we've had a particular amount of water come internally, particularly around the skylights, but I suspect that this insulation that's inside here is wet, but I'm going to do another core drill to determine just how much, or if any. So I can see already there's quite a bit of water coming out, and it's spraying all over. This is the insulation. It's completely saturated right down to the core, holding gallons of water. So that tells me that I need to take up the insulation, I need to get down to the deck and dry it out and put a new system on. The hole I've just done is now filling up with water. It's pretty much like digging holes in sand, this. I'm trying to determine if there's a vapour barrier. What I don't want to do is go through that vapour barrier, because then all this water will go into the building. So that gives me enough knowledge to know what I've got to do to make sure I put this roof back and provide it with a system with a long guarantee.
So thanks to Paul, and we'll be coming back to Paul later to see how Paul rectifies the issues that he found during his site survey. So we'll be covering now some common roof design defects, and these will be generalised, and first of all we're going to look into the structural issues. Existing structures sometimes are questionable, and we need to understand these, especially at the survey stage when proposing a new roof build-up. Historically, there's completely different technologies used, and some of them we need to be very wary of, such as rack decks or reinforced aerated autoclaved concrete, ceramic board and wood wall slabs. In the not too distant past, we've seen rack decks fail. Specifically, there was one case in a school where thankfully it wasn't occupied at the time. These are typically very narrow, long concrete panels that can't deal with the loads and the spans that they're subject to, and ultimately ends in failure. So before we propose a new roof build-up, we need to understand what's there structurally, and we'd always recommend a full structural survey that's detailed if we have questions. The thermal performance. Many buildings that we see on site that are pre-existing, they'll be designed with installation performance to old regulations. So we need to understand that. We need to see if it's damp and therefore not working, and understand what we need to put on top of that to make current regulations, as I can guarantee it'll be completely different to what it was when the building was built. We need to ensure that there's sufficient falls and drainage. As one thing that we do know is if there's ponding water on a roof, we end up with artificially or speeding up the degradation of more waterproofing membrane. In the same way that sun rays reflect from water, it also refracts, and therefore the energy of the UV onto the membrane beneath the ponding water degrades the membrane further and faster than what it would typically. And also the pitch, which also relates to the previous points about falls and drainage. We should always be designing to achieve 1 in 40 as per BS 6229, with the objective of achieving a minimum of 1 in 80. Therefore, we have no backfalls, we have no ponding water, and this takes into account for any deflection or tolerance within the building structure. So, common roof and design defects associated with bituminous membranes. We need to ensure that the product has a low temperature flexibility. This gives it the ability to contract and expand with either thermal movement or building movement. If we have, say, a -5 degree membrane in comparison to -30, the -30 product will have a whole load more flexibility, and therefore the longevity and the risk minimization in terms of shear joints tearing is minimized. And reinforcement in terms of tensile strength. If we haven't specified a product that has tensile strength that's high enough to deal with the building structure and the movement, it's inevitably going to tear, not only on the side laps, but during the actual body of the membrane. So we talked about earlier, either having a polyester mat or a fiberglass mat, or a combination of the two. the combination product offers a much higher tensile strength, so be aware of this one in your specifications. And when we talk about design defects of metal, we mentioned earlier that a standing seam system can work as low as 1.5 degrees. But if we're talking either a traditional metal cladding or a composite system, we always need to be targeting between that 4 and 6 degree pitch. Otherwise, at the weak points, such as the headlaps and the joints, you'll soon see leaks. Wind uplift and loading, that causes big concerns with people. And when we're talking about this, the main issues, especially with a self-supported system, it goes back to a subframe or steel purlins. We need to understand the profile, the gauge, and also the material type to understand the strength of the metal panel that's being specified. At this point, we always recommend it being the responsibility of a structural engineer, but also you can have indicative performance given by your metal roofing manufacturer if they are capable of doing so. Fire regulations and fire breaks, this has become a huge talking point over the last few years, and this has to be stressed at the design stage as well as on site. So we should always have a fire strategy in place, and we should also have a fire officer that is signing this off and checking for compliance. And as mentioned, we need to see this at site stage. We can't just rely on the design details, because often this is misinterpreted, and on site we end up with a defective design because it hasn't been followed as per interpretations of the drawings. And lastly, material incompatibility. Copper and zinc also react with each other very badly, and this is known as bimetallic corrosion, or also galvanic corrosion. And copper and steel, once you add an electrolyte such as rainwater, this can end up meaning that the copper starts to erode the copper starts to erode the steel to the point that the steel disintegrates. So we need to ensure that we have material compatibility in terms of any sorts of reactions that might be applicable between the two different types. And cold applied liquids. Some cold applied liquids, they have a terrible odour. So you don't want to be specifying a really bad smelling odored liquid if you're in a hospital and you're doing a repair project directly underneath their air intake. If you have a horrendous odour into a very sensitive area in a hospital, you're going to inevitably have to evacuate it. And despite many of the odours not actually being harmful to humans, the foreign smell starts to concern people. So we always need to be concerned about the odour in terms of designing and the application where it is. UV degradation, we touched on earlier about UV degradation, and if we don't have rainwater removed from the roof surface, or we have ponding water, you're accelerating that. But some natural liquid coatings, they do degrade with UV, and they're called aromatic rather than aliphatic. So be careful of this. If you're looking for a long lifespan, you're looking for an aliphatic product, not aromatic. And again, material incompatibility, we mentioned earlier about coating PVC, that's fine in terms of single ply membranes, but if we're looking at something like TPO or an EPDM, that material incompatibility is very difficult, and you won't be successfully specifying the correct product. And drainage links into the previous point. We need to make sure that we design sufficient drainage and we get the water off of the roof. So what design defects do we have associated with green roofing? Roofing pitch is key. If we don't have the roofing pitch correctly, we have standing water that builds up during that green roofing build-up. You're going to absolutely saturate what's known as a substrate, or sometimes a soil beneath the green roofing vegetation, and therefore that will eventually die, and then you'll be stripping it all off, reinstating better falls to make sure that you get rid of the water from the roof and do not saturate the green roof. Wind uplift is key. We mentioned this in our Preston project earlier. So even on coastal locations, so long as you consider wind uplift and you either have a pebble band around the outside or paving that sits on the edge of your green roof, you're minimising your risk in terms of wind uplift, but always consider this as part of your design specification. Root resistance is key in terms of your waterproofing membrane below. This is something that's often missed. So if you have a waterproof membrane below, this needs to be a root-resistant waterproofing membrane, purely because if any roots from the green roofing system penetrate down through, and they can get through that membrane, you're completely compromising your waterproofing performance. So always be conscious of this. And the final point is waterproofing above vegetation. We always design to have a 150 upstand in most scenarios between either a flashing or the roof deck. But consider, when you put a green roofing build-up on top of your waterproofing system, you're then compromising that 150. So any adjacent abutments or details, make sure you lift them to match the height of the green roofing surface rather than the waterproofing you have below. So in terms of our defects, what solutions do we recommend that we can offer you? Always follow manufacturer standard details. These are always produced for a reason, and because these are known to be tried and tested details that can last the longevity of a guarantee offered by a manufacturer. But if you do have a bespoke detail, look to your manufacturer to give you guidance on this and produce a detail that they recommend would be sufficient. Follow applicable standards. We talked about drainage standards in terms of 6229, but any sort of British standard out there relating to your roof design, follow them. They're tried, tested methods, and they're there for a reason. Building regulation compliance. We've talked about fire earlier on in the presentation, and there's also a whole load of other approved documents you need to follow. So do follow these; they're in place for a reason. But ultimately, seek expert advice. This is the best place for you to ensure that your design is specified as intended. These guys have a whole wealth of knowledge and expertise in doing surveys, specifications, application and attendance on site, as well as the aftercare. So always consult your roof manufacturer and seek that expert advice to give you that assurance. So I'm going to hand you back to Paul, who's going to take you through what he's done in terms of resolving the issues we found earlier on in the site survey.
So what was evident on these roofs is that there was a lot of ponding water. Main reason being that the roof outlets were too high. So we've insulated this roof, we've put a hard edge of timber around these outlets and we're going to endeavour to sump the outlets. So this is what we've done here. So we're utilising the existing falls, but we're making sure that the lowest point of the roof where their outlet is maintained low, and most of the water can be directed into it.
So thanks to Paul, and we'll be going back to Paul later to look at some aesthetic defects that he's also seen on site. So during this section, we're going to talk about application defects. And two of the key things are weather conditions and also insulation type. So firstly, weather conditions. As you can see from the image on the right, we have exposed quilted insulation. If this starts to rain and this insulation gets wet, you're going to completely compromise your U value and the thermal performance of that roof. So you always need to plan ahead and be aware of the current weather conditions and the forecast ahead. We've also touched upon how key it is for liquid membranes. If it's raining, you cannot apply that. So we need to be very conscious of weather. And in terms of insulation type, there's different facings on different types of insulation, and particularly bituminous membranes. We need to understand this and make sure it's specified correctly. So typically, if we're torching a bituminous sheet or a bituminous membrane, we'd look for a bituminous coated fleece on top of one of our insulation boards. Or if it was, for example, a self-adhesive system, we look for a tissue-faced insulation board that's primed. So we always need to ensure insulation compatibility, which with whatever roof waterproofing system that we are recommending. Application defects in terms of bituminous membranes. Temperature is key. If we don't use enough temperature, you won't melt the bitumen, it won't bond. But equally, if you use too much, you'll completely blow the body of the membrane apart, and you'll be ending up with a real thin membrane and compromising the performance that you should get. Insufficient side laps and head laps. We always recommend on the side between 75 and 80 mil, on the head laps anywhere between 150 for details and 100 standard. Compromising this, you're compromising your waterproofing performance. And we always recommend laying in the break bond patterns, similar to what you'd expect in brickwork. And the reason for this is if you experience thermal contraction and expansion by staggering the joints or having them broken, you are minimising the risk of having a localised tear with joints in the same place. And fixing on sloped surfaces, there's some guidance in terms of British standard, which is 8217, and this defines how much you should be fixing bituminous membranes on sloped roofs, depending on the slope. So always make sure we're adjusting this if you have bituminous membranes on the slope. And common application defects in terms of metal. You're always going to end up with joints, head joints and head laps and side joints rather on metal. And we need to ensure that we seal these correctly, otherwise you're going to be inviting leaks in immediately after install. Ensuring the correct fasteners and fixings are used. If they're not compatible or not the right ones, you're either not going to get the correct torque, as we talked about earlier, or they will literally come apart from the substrate you're fixing down into. And equally, the number of fixing points. You should be given guidance on this by the roofing manufacturer and the structural engineer if they're involved, to make sure we specify the correct amount of fixing points per metal panel. And equally, flashings. Flashings on metal roofing is typically a lot more difficult than other roofing applications, and we need to ensure these are both signed off, sealed, and giving you ultimate roofing protection at the difficult junctions and details. Liquid roofing systems, we've already mentioned that the temperature is very, very key for liquid coatings. If it's too hot or too cold, you can get two types of reactions. Either the liquid will not cure, which you can end up with a soggy mess, or if it's too hot, it can sometimes cause an overreaction of CO2 give off, and therefore you'll see lots of bubbles within the application. And also the application thickness. So if you've got a skilled contractor, they're typically going to have the thickness very consistent and very smooth, where if you have a contractor that's not so skilled, that the application thickness will vary, and therefore you're not only going to find ponding water, but you're not going to see a seamless finish that you'd expect from a typical liquid applied coating. Yeah, and this is something you need to be wary of, especially on the tricky bits and the junctions and details, because if you're compromising that thickness, you're compromising your waterproofing performance. Green roofs are very, very sensitive items, and in terms of application defects, we can completely ruin the system within the first day of them being delivered to site. If they're not installed within a day or two of the green roofing system being delivered to site, the same as if you had rolls of your lawn delivered at home, if you're not laying them and watering in situ, they will degrade, they will die, and there's no point even laying them. So we need to be very careful in terms of the handling, how they're handled on site and when they're laid. And secondly, the installation in terms of time of year. You need to give the green roofing system and the vegetation the best opportunity to thrive and to establish itself. So this is typically in the spring and summer months. If you were to install it during the autumn or winter months, the green roofing system will not establish itself and will likely die in the not too distant future after install. So what solutions do we recommend in terms of avoiding application defects? Look for your skilled contractors. If you're having skilled contractors on site that are tried and tested and they're also trusted amongst other people in the industry, the likelihood is you'll be avoiding a whole load of application defects and avoiding any risk associated with that. Weather. If we're avoiding bad weather in terms of rain or hot and cold temperatures, you're likely to be minimizing any risk associated with a system not working correctly or compromising U values of wet installation, etc. Expert site inspection. So if you have a roof manufacturer, that they will typically have technical experts that will attend site post specification being delivered, and these guys can ensure that everything that's being installed on site is per manufacturer specification, and you can avoid any application defects. And also, if it's beneficial for you guys, ask for manufacturer training. The good manufacturers out there on the market, they will provide you training, they'll provide you CPDs, and as a result, you guys will be better at specifying, and you'll be avoiding the application defects from misinterpretation from either specifications or install guides that you might have to provide to site. So in this section, we're going to cover some aesthetic defects, and we'll start with bituminous roofing. So as part of the standard, you can lose up to 30% of the mineral on top of a bituminous membrane. But the issue is if you have excessive loss of the mineral on top of a bituminous cap sheet, it does look unpleasing, and you see the black or the shiny surface beneath with the bitumen. So we need to avoid this. Material thickness and defects, in terms of the defect. If there's a varying thickness of the body of the bituminous membrane, not only will you see ponding water again, but you'll see an uneven surface as a result of the varying thickness. So we need to avoid this. And sometimes we get contamination in terms of the bituminous compound. And what this will lead to is when you apply heat to the membrane or a torch, you end up with blistering that is commonly referred to as baby blueberries. That's what they look like once a contamination has been found by the torch, and it will give CO2 off, which eventually leads to the blueberry. Inconsistent laps and roll widths. Skilled contractors of bituminous membranes are very specific about how they set out their bituminous roofs and where the laps, where the joints are all set out on the roof. But if you have a product that doesn't have consistent lengths, consistent widths, you'll soon lose that symmetry that the guys on site are so desperately working hard to maintain. And obviously that's not nice to see. And here in the UK, in comparison to some other places in the world, it's something that we actually pride ourselves on in terms of the aesthetic for symmetry of bituminous membranes. Aesthetics of metal. Delamination is a big one. The coating that's applied to any type of metal substrate, albeit aluminium, steel, whatever it may all be, they do sometimes delaminate and they do come away, which does look unsightly. But this can be easily managed by having regular maintenance or identifying localized patches where this is occurring. If we deal with that localized patch, that will stop it from spreading. If it's not, then the delamination will spread very quickly and you'll be in trouble. Incorrectly shaped profiles. So sometimes if there's a profile that's not matching the rest of the roofing sheet that's been installed, you might get a slightly different batch or a slightly different roll former that ends up giving you incorrect shapes. Again, unsightly. You want a consistent, clean finish. And then finally, poorly designed or installed flashings. Sometimes flashings are missed and they look like an afterthought, and it's very obvious on a metal roof to see when this is. They won't look continuous, and they will certainly look an afterthought. So if they haven't been considered, designed and installed correctly, these will look unsightly and will certainly be classed as an aesthetic defect. So for the last time, I'm going to hand you over to Paul, who's going to go through the aesthetic defects that you picked up during the site survey that we've looked at earlier in the CPD.
I think a lot of these roofs are have had a bit of an issue because the lead's been taken by vandals at some time. One thing I've spotted here is this lead flashing is not continuous, and there's an obvious gap down below which is giving direct access for any water to get in.
So thank you to Paul, who kindly done these videos for us and points out the poorly designed and installed flashing on that project. And finally, we're going to finish off with the aesthetic defects. And in terms of the cold applied liquid, these are very sensitive in terms of their lifespan. So if you had, it's anywhere typically between 9 months and 12 months that these products can be on the shelf. If they exceed that, the likelihood is the consistency of the product changes, and therefore achieving a good finish is very, very difficult, and you can get contractors that are very unhappy. And sometimes you have fluctuations in formulation issues because they are very complex products to form. And if your formulation slightly changes between batches, that's also going to change either the consistency or how the system reacts if you're applying it to an upstand or on the field itself. Sometimes that means that if you're, for example, applying it with a roller, when you're applying that to the liquid, you'll start to see drag marks. And instead of that self-leveling, you'll see that finish on the liquid membrane, which again, we're looking for a seamless finish with a cold applied system, cold applied liquid system, and the contractors won't be too happy, neither will the client. For application, well, we've touched on how important it is to have skilled contractors that are recognised and known for being skilled. If you've got someone that's not so skilled, you'll be struggling to get a quality finish. So always be wary of this. And inconsistencies in colour. There's a very good example on the right-hand side of your screen there, where between batches, if a different pigment colour is used or there's been a difference from an alternative source, you will have differences in the aesthetic and a difference in colour. And again, leading to a very upset client. So aesthetic defects in terms of green roofing. We can get deterioration very quickly if we're not having any type of maintenance. We mentioned for a cedar roof, you can maintain this very minimally in terms of once a year. But if there's a lack of watering during drought periods, I mean, there's only a few years ago we had severe drought and green roofs had to be watered during the summer months, it will start to degrade and deteriorate. And in soil erosion, if we have the opposite to a drought and we have huge amounts of heavy rainfall, this can actually end up washing out, or the level of the green roofing system start to change. So if this is seen, we need to address this quickly, otherwise the green roofing system will essentially disappear. And one of the biggest threats of green roofing systems is invasive plant life. So although we've specifically designed the system to have different types of plants that are suited to our application, you could have invasive plants either by a seed that's dropped by a bird, and these can quickly overcome and take over a green roofing system. And this is why maintenance should be done even at least once a year, even on a low maintenance system, to identify invasive plants and remove them as soon as possible. So, in terms of aesthetic defects, what are our solutions? Go with a manufacturer that has a good reputation and is known in industry, and also choose manufacturers that are known to conform and comply with ISO standards in terms of quality control standards, health and safety, managerial. There's a whole list of ISO standards to comply with, so please check up on that. And then finally, MBS is a great platform to be able to ensure that your manufacturer is meeting certain criteria. Not anyone can be part of the NHS platform, and this is a good indication on the quality and performance of a manufacturer's products. So today in the CPD, what have we covered? We've gone through the different types of waterproofing systems available on the market. We've identified some advantages, disadvantages, and how we specify them on the correct type of application and what type of sectors they use on typically. With the help of Paul, we've looked through some tools and techniques in terms of surveys, what we need to look out for, how we address them, and how we can assess this and make sure that we're compliant and also not open ourselves up to any risk. And the large section of this presentation has been based on defects in terms of design, application, and aesthetics, and also how we can avoid them, what we need to look out for. And then finally, we noted what we should be expecting from our suppliers. If you're associated and working with a well-known and accredited manufacturer, you'll be avoiding as many defects as possible from the get-go. So I hope you found this presentation, this CPD webinar, informative and interesting. And I'd like to ask if anyone has any questions. My colleague Charlotte has been monitoring the question box throughout this presentation, so we'll go through them now. But if there's some questions we can't quite get to, we will pick this up and we'll get back to you in due course.
Okay, so the first question is from Chris. He asks, are there any types of defects that should be considered when using solar panels on roofs?
Hi, Chris, and great question. Solar panels we're seeing a huge amount more from nowadays. People are trying to reduce their carbon footprint, and it's how we integrate these onto roofs without inviting defects. So our preferential way that we'd always recommend is having a ballasted system. So therefore there's no penetrative fixings, and this would typically be associated with flat roof applications. And we'd also insist that on the bottom of a PV system or on a ballasted PV system, the feet are either rubberized or there's a sacrificial layer underneath, either of another bit of membrane or a neoprene or rubber mat. That would firstly be our preferential option. But ballast obviously increases load and weight to a roof system. So if it's a refurbishment, it might not be possible. Therefore, you might go for, say, a Nicholson roof track system where you integrate a membrane and fix that down through into your substrate. This is also a good idea. We do it quite a lot here. And this doesn't add the extra weight to a roof if you're limited on capacity. Metal roofing systems is quite a bit different. And if you're looking at a traditional metal roofing system, we'd have to fix down through. And again, it's the same principles we looked at earlier. We need to ensure the correct fixing is specified, that the correct torque is done, so the EPDM washer underneath is compressed and sealing off any voids. But if it's a standing seam system, you can have a clamp that's easily on top. And if that clamp is compatible with the standing seam profile, you'll be avoiding any defects and you'll be good to go. So hopefully, Chris, that answers your questions with PVs and how we integrate them on the roof without inviting defects.
Thank you. The next one is from Alex. He asks, I work with NHS trusts who often require flame-free roofing products on their projects. Are these actually reliable in the long term when compared with metal or torch applied bitumen membranes you talked about?
Hi there, Alex, and thank you for your question. Safety torch is a very prominent topic that we're coming across at the moment, and you point out a very good point. So torch-on systems, depending on the quality of the membrane, will typically last longer than the self-adhesive because you're torching and actually bonding that membrane to your substrate. Whereas a self-adhesive system, you're relying on the self-adhesive compound to simply get the safety torch accreditation that's so key for us now. There are some other things we can do to increase the longevity of the self-adhesive system, which is to use a different type of primer than what you typically use. If you use a primer that's specifically developed for a self-adhesive system, you'll get a much better bond and you'll be giving yourself the ultimate longevity that you'd be after, despite using a self-adhesive system rather than a torch system.
Okay, next one's from Matthew. He asks, what are some of the ways you can design out fire risk on roofing specs?
Hi there, Matt. We mentioned earlier on this presentation that having a fire strategy and a fire officer is absolutely fundamental. I mean, a fire strategy sets out what you'll be trying to do on a project, and a fire engineer will confirm that, check it, and make sure you're absolutely compliant, which we would always recommend to be doing on a project. And in terms of designing out risk for the roof itself, always ask for a fire certificate. So a lot of the roofing membranes or roofing substrates on the market today will be tested to B-Roof T4. And you'll see in Part B the approved documents that if you're immediately adjacent to a building, you'll be looking for a B-Roof T4 system, and this slightly changes depending on the adjacencies, which I'm sure you guys have seen or read up on before. But always look for that fire certificate as well, because in that fire certificate there'll be different build-ups that's been tested, and you want to make sure that's applicable to what you're specifying. So it might be just tested on a bit of plywood. Some will be tested on the plywood with a whole build-up that will be representative to your project. So we're doing that, you're designing out risk, and you've got a piece of paper to ensure you that you're achieving B roof T4, regardless of what your build-up insulation type is, etc. Thanks.
Okay, next question is from Lee. He asks, why does Garland not offer a single ply solution? So he also mentions PVC and TPE.
Hi there, Lee. Thank you for your question. Ultimately, it's the longevity of the system. We replace a lot of single ply roofs, and I guess our concern with single ply roofs is the robustness and, as I mentioned, longevity of that system. Whereas something like a bituminous membrane, that can last 30, 35, 40 years. And although single ply is a relatively new technology in comparison to something like bitumen that's been around for tens and tens of years, it's purely the robustness and the longevity that we're looking for. So that's the reason we don't do single ply. We never have, and in honesty, we never will. But we're happy to keep replacing them.
Okay, final question now. This is from Paul. He asks, when it comes to Garland attending site to carry out core samples, do you recommend the most appropriate product to use, and do you have preferred or approved installers for that?
Very good question. So we have technical experts across the UK, which I can tell you a bit more about as we conclude the CPD. These guys will attend site for you, and they will give you all the best recommendations that's up to industry trends, recent regulations and legislation. And what they'll do is they'll guide you from initial site survey. They'll give you it's called a ramp report for us, and that will set out everything they find during that survey. If there's localized moisture penetration down through the installations we mentioned earlier in one of our precedent projects, and it will basically define in that survey what needs to be done to get that project back up to standard and minimising any leaks in that project. So that's the first step. And with that, with your instruction, they'll form a specification, and that specification will ultimately give our best guidance on what we would recommend to do to that roof. And you can take that, adapt it with our guidance, and they're ultimately there to give you a single point of contact and ensure that when you produce a specification, it's robust, you're happy with it, and we can offer a long guarantee off the back of it. And then site inspections, as you mentioned, if a specification does get instructed to proceed and that project gets to site, at key milestones, typically weekly, our technical managers will be on site to inspect all the details, inspect how it's been installed, and sign off at each stage. And each one of these stages, you'll see a report. So you guys specify if you insist on seeing a report at key stages. You can also see this to ensure that it's being installed as per specification and as per our recommendations. And then finally, it's the aftercare that's important. It's not a case for us of installing a roof and then running away from it. We offer long guarantees off the back of it that we need to be satisfied with. So therefore, that's why we do the site inspections, to ensure compliance and robustness in our details. And then the aftercare is that we look after it for however long the guarantee is, 15, 20, 25, 30 years. But yeah, any of our guys, if you type in onto the website, Garland UK, find my expert, you can find your local expert that's local to you guys, and they'll be happy to help. And these guys, you know, they're highly trained technical experts that job for hat will be there to help you and hold your hand if necessary throughout the duration and length of the project. Well, thank you so much, guys, for attending. I hope you've enjoyed the session today. And as I mentioned, please reach out to our technical managers and search them on the internet. They'll be happy to help. Or feel free to email Garland Technical, where any of us guys can help you as well. Thank you and goodbye.